Hello class, today we're talking about modeling expressions using algebra tiles. Expressions are composed of coefficients, variables, and constants, and we've given you an example down here below. Coefficient is pointing to this 3, the variable is pointing to this x, and constant is pointing to this 4. So we got to break down what exactly those things are. So coefficient is a number used to multiply a variable. For example, this 3x means I'm taking 3 and I'm timesing it. I'm saying 3 times x, where x is the variable. Now a variable is a symbol for a value we don't know yet. It's usually a letter. You might see it as X, Y, Z, A, B, C, D, the letters of the alphabet. So it represents something we don't know yet. Expressions can be modeled with algebra tiles. Algebra tiles come in the shapes of squares and rectangles. We have them here as, I guess, white rectangles and squares and black rectangles and squares. In class, we'll probably use more positives being yellow and the negatives being red. So just kind of keep that in mind as we're going through this. I'm just going to be using black and white because I think that's a lot easier and we don't have to worry about switching back and forth between the colors. But just remember, if it's positive, it's going to be either yellow or white, and if it's negative, it's going to be black or red. So again, those rectangles represent x or negative x, and the squares represent 1 or negative 1. So when I ask you to model, when I say model 3x plus 4, it means, okay, how do I get 3x's? What do 3x's look like? And then what does 4 look like? Well, I know 1x is one rectangle, so if I want 3x's, what do you think? Let's just draw 3 rectangles. Cool, and then what does 4 look like? Well, if 1 is a little square, 4 just tells me, okay, let's just draw 4 little squares. So this right here represents 3x plus 4. Let's go over here to this next one. Model negative 2x minus 3. Well, if negative x is a shaded in rectangle, I'm thinking negative 2x means, well, let's just put another shaded in rectangle right next to it. So I know what one of these looks like, so if I want 2 or 3 or 10, I'm just going to put that many rectangles. And again, if negative 1 looks like, oh, this is a typo. This should be negative 1. If negative 1 looks like one filled in rectangle or square, negative 3 means I should have 3 filled in squares. And the same goes backwards as well. If I know what each of these things represents, then I can take the squares and the rectangles and I can turn them into numbers and letters. So I've got 1, 2, 3, 4 rectangles. Awesome. So I know there's going to be 4 x's. I just got to double check, are these positive or negative? Well, they're white. They're not shaded in, so they're positive. Okay, cool. And then I see these 1, 2, 3, 4, 5 little squares. So I know there's going to be a 5 somewhere. And then I have to check here, are these positive or are they negative? Well, they're shaded in, they're black. Tells me it's going to be negative 1. So I'm going to write a minus sign. So this expression is really 4x minus 5. Let's jump over to this next one. What expression is modeled below? Again, I see one rectangle. That tells me it's going to be an x. I could also write 1x. But usually as mathematicians, we like to be lazy. So I'm not going to write the 1 if I don't have to. But there's 1x. It's negative, right? Because it's a black rectangle, it's going to be negative. And then how many of these little squares do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I'll write 8. And is it plus or minus? Well, they're white squares. They're not shaded in, so it's a plus. And I have my answer. There are a couple more that I would like you guys to try on your own. You can pause the video, rewind, look at what I just did to maybe help you out with these. But I will give you the answers in class. Thank you.